Good morning to all. I, Dr. Kirti Kumar Jain, Assistant Professor of SIRT College, Bhopal. Here we discuss about the differentiation. We know that differentiation is a very important topic for students because it is used in many fields. Differentiation divided into many parts because it is very large topic. Therefore, we divided differentiation into many parts. There are simple differentiation, order differentiation, and partial differentiation. So these parts are divided into some lectures. So this is my very first lecture. This is my very first lecture. In this lecture, we discuss about the definition of differentiation and basics of differentiation. So differentiation is very large topic and play important role in mathematics. There are many definitions of differentiation given by mathematicians. So one definition are here that differentiation is one of the important concept is mathematics, which is a method of finding the derivative of a function. Differentiation is a process in mathematics where we find the rate of change of function which is based on the its variable. The most common example is the change in the rate of displacement over time, which is called velocity. The opposite of finding the derivative is called antiderivative. If y equal to fx is a differentiable function of x, here y is differentiated with respect to x, which is dy by dx. So here dy by dx means differentiation of y with respect to x. So dy by dx equal to limit h tends to 0, function of x plus h minus fx upon h. This is a general formula of differentiation. All standard formulae, all other formulae of differentiation are depends on this formula. इस एक फार्मूले से हम बाकी सारे फार्मूले बना सकते हैं. So this process of finding the derivative is called differentiation. Now the geometric definition of derivative. The derivative of a function of x at x equal to x naught is denoted by f dash x naught. So it can be defined as the slope of graph of f. F means function at x equal to x naught, which is given in this graph. Therefore, we define the slope of the graph of function f at a point x naught is the slope of the tangent to the graph of at point x naught. This tangent can be thought of into base x naught, fx naught, and x fx. So edge, the line which closest to graph near the point x naught, fx naught, and the limit of intersection lines passing through the adjacent point x, fx, as x approaches to x naught. This graph is represented by geometrical definition of derivative. Now, graphical representation of differentiation. So here we represent graphically a differentiation. Since we know that all mathematical terms have a graphical representation. So if we talk about a derivative, it actually means the rate of change of one variable with respect to another variable. And we can take the derivative of any differentiable function. If possible, we can take the first derivative, we can take the second derivative, we can take the third derivative, and we can take up more derivatives of function. When we differentiate function, we only find the rate of change. And when we take derivative, the graph also changes. And if we take second, third, fourth derivative, then the graph changes again. So this is a graph of derivative function. So the three basic derivatives are differentiating, algebraic functions, trigonometric function, exponential function. And we find some more derivative like logarithm function, implicit function, parametric function, and function of function. So these functions are differentiated. Some example of the function which we have given previous. So first example of algebraic function of x, x square, x cube, or other variables. Trigonometric functions, sin x, cos x, tan x, sec x, etc. And the example of exponential function is in the form of e to the power x. Logarithm function is log x, and the example of implicit function x plus y, or x square plus xy square plus xy, etc. Parametric function x equal to function of t and y is also equal to function of t. And function of function sin x square, sin x, log 10x, e to the power x, sec cos x, something, etc. And the inverse function sin inverse x, tan inverse x, cos inverse x, sec inverse x, etc. So these are the examples of functions. Now this is some assignment problems for the students, and thanking you.